Every great structure begins with something that looks almost like nothing, an empty piece of land. But before a single column is constructed, an engineer must first understand the ground beneath it. Soil investigation, site conditions, foundation requirements, and the intended use of the building all form part of the decisions that come before construction. The building may not exist yet, but its structural story has already begun. This is where the engineer begins to turn an idea into a structural plan. We look at the site, study the proposed building, and begin asking important questions. How will the building carry its weight? Where will the columns stand? How will the loads travel from the floors, through the beams and columns, down into the foundations, and finally into the soil? Structural engineering is not simply about making a building stand. It is about understanding how every part works together. Before concrete is poured, the structure exists first on paper and inside calculations. Structural drawings communicate exactly how the building is intended to be constructed. We identify beams, columns, slabs, foundations, and reinforcement details. Every dimension matters. Every connection matters. And the reinforcement shown on these drawings is designed to help the concrete resist the forces acting on the structure. Today, engineers can take the structural concept much further using digital modeling. A three-dimensional structural model allows us to visualize the building as a complete structural system. We can define columns, beams, slabs, supports, and loads. Then analyze how the structure responds. The computer does not replace engineering judgment. It gives the engineer a powerful tool for understanding and checking the structure. Structural engineering also has another side that is rarely seen. The calculations behind the drawings, the checking, the revisions, the questions that must be answered before construction begins. Is the beam adequate? Is the column carrying the expected load? Is the foundation suitable for the soil? Good engineering requires patience, because a structural decision made on a computer can eventually become a physical reality on a construction site. But construction does not happen inside a computer. Real sites face rain, heat, wind, muddy ground, and unexpected conditions. Fresh concrete and exposed reinforcement must be properly protected. Water management becomes important, and construction activities must be controlled carefully. The engineer must constantly compare what is happening on site with what was designed on paper. Now the structure begins to rise from the ground. Here, reinforcement bars are being positioned according to the structural drawings. The reinforcement helps the concrete resist tensile forces, while the concrete provides strength and protection around the steel. Before concrete is placed, the engineer must check important details, such as reinforcement size, spacing, cover, dimensions, and positioning. A foundation is not simply a block of concrete. A building's strength begins beneath the ground. The foundation receives the structural loads and transfers them safely into the supporting soil, while reinforcement helps the concrete resist the stresses it cannot handle alone. As construction progresses, the structural system becomes visible. Columns transfer loads downward. Beams support the floors and transfer their loads to the columns. Slabs carry the loads generated by people, furniture, and other building activities. Together, these elements create a continuous load path down to the foundations. What appears to be a collection of concrete members is actually one connected structural system. After months of design, calculation, detailing, construction, and inspection, the structure finally becomes a building. But what we see on the outside is only the final expression of thousands of engineering decisions. The foundations beneath the ground, the reinforcement inside the concrete, the beams and columns carrying the loads, the calculations behind every structural member. Good structural engineering is often invisible, because when it has been done correctly, the building simply stands. And perhaps that is what makes engineering so powerful. We begin with an idea that exists only in the imagination. We turn that idea into drawings. We test it with calculations. We build it with materials, people, and precision. And eventually, something that once existed only on paper becomes part of the real world. Because every structure tells a story, and behind every great structure, there is an engineer who imagined what could be built. If you enjoyed this journey from idea to reality, don't just watch, become part of the journey. Subscribe to P&T Smart Mind and turn on the notification bell, because here we explore engineering, construction, technology, design, and the ideas that turn dreams into reality. If you found this video useful, give it a like, and tell us in the comments, what would you like us to explain in our next video? Your questions, your ideas, and your comments help us create better content for you. This is P&T Smart Mind. Dream, design, build. See you in the next one.